Hello, Matthews Gatos here. Welcome to Chapter 6, Lesson 6, Horizontal and Vertical Shifts. So we're building on what we did last time in Lesson 5 with amplitude and period, your A and your B parameters. Okay, let's explore horizontal and vertical shifts graphically. Let's talk about a base sine function here. A base sine function starts where the midline, in this case the x-axis, and the y-axis meet. At that point, sine should start midline on an upswing. So we need to be able to recognize, has that starting point changed? So if we go over here, here's the midline. You can see I start midline on an upswing. So there has been no horizontal shift. There's been no left or right movement. Okay, let's look at this diagram here. So this diagram here, I want to draw in the midline, and I want to look where the midline and the y-axis meet to see if there's a new starting point. So here's midline on an upswing, midline and y-axis on an upswing. And you can see that is not where I start. So the graph does not start here on an upswing, so I know there has been a horizontal phase shift. Now, all we have to do in 30-2 is recognize if there has been a shift. We don't have to talk about the direction. Does it go left or right? We don't have to talk about how much it's shifted. Just recognize from a graph and an equation that a shift has occurred. Now, when we have shift, a horizontal shift is called a phase shift. When we have a shift to the sine graph, moving it left or right, it will change the starting point and both the x and y intercepts. Let's talk about vertical shift. So vertical implying up and down. So diagram 3 and 4 below have had two different shifts. In diagram 3, there's been a vertical shift of 1 unit up. So if there's a shift of 1 unit up, that means that the midline also goes 1 unit up. And in diagram 4, we've had a shift 0.5 units down. So this also goes 0.5 units down. So the vertical shift is represented by the median. So I went up 1, now my new median is at 1. I went down 1/2, so now my median is at -1/2. When I have a vertical shift, moving the graph up and down, it will change the midline, the max, the min, and both the x and y intercepts. So midline is the halfway point of a graph. So it's an imaginary horizontal graph that splits the graph into half. Now, a little typo in your workbook, if you wouldn't mind correcting it. If the midline is above the horizontal axis, which just means x-axis, then I've shifted up. If the midline is below the horizontal axis, which is again just the x-axis, the shift has been down. Okay, let's look at this example here. We want to refer to diagrams 3 and 4 and draw the midline of each graph and then state the equation of the midline. So you can see here, normally this would be what splits the graph in half, but you can see that's not it. So we want to go to the end where we're going to match up those two end points. So starting point to here. So I can see I have an equal amount above and an equal amount below. So in this case here, the equation of my midline would be y equals to 1, because I see that I'm going up by 0.5s. Okay, in this next one, normally the midline is here, but you can see I don't have an equal amount above and below. So I have to actually just shift it. And right there, it's an equal amount above and below. So this midline would be at -0.5. Okay, relating the phase shift and the midline. So we can actually use the starting point of sine to see if there's been a vertical shift. Now, sine starts midline and y-axis where they meet right there at the start on an upswing. So if this midline is not the x-axis, there's been a vertical shift. Okay, let's look at this diagram here. So we have the original sine function done in the thin black line, and there's been a transformation or a change in the thick black line. Now we want to determine if the sine function with the thick line is different with regards to amplitude, period, horizontal phase shift, or vertical shift. We're going to check all the ones that apply. Okay, so I always like to start with the midline. So normally the midline is at the y-axis. Okay, but I can see that is not an equal amount above and below. So I have to actually move it, and I'm going to move it down. So since I've moved the midline down, there has been a vertical shift. Now, normally my amplitude is a unit of 1. So do I have 1 unit above the midline and 1 unit below? No, I have considerably more. I have 1, 2, 3, 4. So it looks like the amplitude has been changed as well. Has the period been changed? Normal period is 1 cycle, a hill and a valley in 2 pi. If we trace this out, a hill and a valley, still 2 pi. So the period has not changed. The last thing I want to check is, has there been a horizontal phase shift? So look at the starting point, midline and y-axis. It should start right there on an upswing. And it does, so there's been no horizontal phase shift. Okay, looking at the next example. Again, always start with your midline. So looking at my midline here, I can see I have an equal amount above and below. So that means that my amplitude has not changed and my vertical shift, there has been no vertical shift. Let's talk about horizontal phase shift. So I should start right there on an upswing. And you can see I do not start right there on an upswing. So there has been a horizontal phase shift. And let's talk about period. Period is 1 hill, 1 valley in 2 pi. So if we look here, I don't see hills and valleys, but I do see max to max. So max to max should also be 2 pi. And you can see max to max here. This distance here is not 2 pi. So in between here and here is not 2 pi, which tells me that I have a change in the period. Okay, we're going to get rid of that. And we're going to look here. A phase shift will only occur in the equation of a sine expression or function expressed in the form y equals a sine bx plus c plus d. If there is a c value that is not 0, there will be a horizontal phase shift. Again, you don't have to tell me which direction or how much, just if there has been a phase shift. So here's some examples of horizontal phase shifts. So see inside the brackets, 3x plus 4, x minus 4, 4x plus 2, 4x minus 7. It doesn't matter what's going around. Just inside the brackets, if I add or subtract anything to my x value, there has been a horizontal phase shift. Here's some non-examples. All of these ones here have nothing added on to x. See right here, this is not added on to x. This is a d value on the outside. If it was added on to x, it would have brackets like that, but it doesn't. Same thing here. If it was a c value, it would have brackets here, but it doesn't, so there's no c value. All of these have a c value of 0. So examples and non-examples. Let's look at the graphs here. We're going to explore the graph of sine x plus d. And again, remember that trick I showed you in the last video. Zoom 6 is a quick way to do a trig window setting. Okay, for each one of these graphs, I want to state the amplitude and the period. So amplitude, I learned in the last lesson, is the a value, the number in front of sine x. And I can see the number in front of all of these is just 1. Okay, in the last lesson, we also learned that period is 2 pi over b. b is the number in front of x. So look at the number in front of x for each one of these. They are also 1. So the period is going to be 2 pi over 1, which is just 2 pi for every single graph. So it looks like your d value here does not affect amplitude or period. So d is the number added or subtracted at the end of the equation. Let's look at what it does affect. Okay, vertical shift. So let's talk about the base graph, which is the blue graph here. The blue graph in the middle is just sine of x. So there has been no vertical shift. Look at the red graph here. See how it has a plus 2? That means that graph has gone up 2. You can see I'm going up 2 all my units. Okay, this graph here, sine x minus 2, the minus 2 at the end there tells me my graph has gone down 2 units, as the arrows there indicate. So my midline value, when I have a base graph, is just y equal to 0, so right at the x-axis. This red graph, because it's been moved up 2, the midline also moves up 2 and has a midline at y equals to 2. This graph here, sine x minus 2, has been moved down 2, so the midline value and the equation of the midline would be y equals negative 2. Okay, and then the d value, of course, is the number that is added on at each one of these, at the end of each of those equations, which is also the midline value. So how does the midline value of a sine function compare with the parameter d? Well, d is the midline. So you can now tell, looking at an equation, what the midline value is. So without graphing, let's state the midline of each of the following equations. I have sine x plus 10. The midline is y equal to 10. I have sine x minus 4. The midline will be y equal to negative 4. And then in general, sine x plus d, I have my midline as y equal to d. So remember, midline is a horizontal line. That's why they are all y equals equations. So y equals equations because the midline is a horizontal line. Okay. Let's look at this one here. So I'm going to give you some equations, and now we're going to determine max, min, and midline value. So midline value we know is our d value, which is the number that I've added on. I've added a new equation here to your table. So replace your table with this new equation. So I know that my d value is added on at the end here. So all of these have a d value of 5. So if you think about the midline, if this is the midline, and the a value is the amplitude, if I go up my amplitude, I'll be at a maximum value. So that's why for maximum I do midline plus amplitude. If I go down the amplitude, I'll be left with my minimum value, which is why I say that d minus a is your minimum value. So max value d plus a. So 5 plus imaginary 1 in front, 6. 5 plus 4, 9. 5 plus 2, 7. 5 plus 3, 8. Again, your minimum value, midline minus your amplitude. So 5 take away the invisible 1, 4. 5 take away 4, 1. 5 take away 2 is 3. And 5 take away 3 is 2. So again, looking at your equation, you can now determine your max and min, which would be really useful when we come to window settings. So you can see I have two of the graphs here just to kind of confirm. Sine x plus 5 has been moved up 5, and you can see the maximum value here is at 6, the minimum value here at 4, so I know that I'm correct. The red graph here, I have my minimum value here at 1. And my maximum value at 2, 3, 4, 5. There's the midline value at 5. And maximum value at 9. So I know that that is correct as well. Okay, what do you notice about the midline values? Well, in this case here, the numbers added on at the end were all 5. So all of the values were 5. The number added on at the end. So in general, when I have a sine bx plus c, all plus d, the midline value depends on the value of which? Does the midline value depend on the value of a, b, or c? So for this equation, the midline value only depends on the value of d. Okay, this is your midline value. Your a is your amplitude. That's just the distance from the midline to the max, midline to the min. Your C value is just your horizontal phase shift. And your B value is determined, is used to determine period. It's those number of cycles in 2 pi radians. So the only thing the midline value depends on is the value of D. How can the midline value be determined? Using only the max and min values. Well, since it is the average height, I take the max and the min, add them up, divide by 2. Okay, so characteristics associated with parameters C and D. Changing the parameters C on the graph means you introduce a horizontal phase shift, a left or right movement. Changing the parameter of D on your graph means you have a vertical shift, changing the midline, the max, and the min. So if the D value is greater than 0, we're going up. If the D value is less than 0, we're going down. So looking at all of the equations here, we have amplitude, which we had last time, and period, which we had last time. So the A and the B values were in lesson number 5. These are in lesson number 6. Now, notice the only equation there that's on your formula sheet is in the blue box there, the period. Period is 2 pi divided by b. The other values you want to memorize. So if you remember, amplitude is half the distance between max and min, which is why I subtract. Midline is an average height, which is why I add and divide by 2. And C is just the horizontal phase shift. So in your equation, if you have a C value that's not 0, it means you've had a horizontal phase shift. Let's look at class example number 5. So for each one of these, I want to determine amplitude, period, and equation of the midline. So starting to put everything together. Okay, so amplitude is the number in front of sine. So 6 is in front. That's my amplitude. Imaginary 1 in front. 0.5 in front. Okay, period for each one of these is 2 pi divided by my b value. So a number in front of x there is a 1, so it's 2 pi divided by 1, which is just 2 pi. In the next one, the b value is 4, so 2 pi divided by 4. Put that in lowest terms, and I get pi over 2. And here the b value is 0.5. 2 pi divided by 0.5 means my period is 4 pi. And then lastly, we want to do the midline. So the midline is the equation y equal to d. So d value of 1, y equal 1. No d value there, so y equals 0. And d value of 0.5. So which of the following functions has a phase shift? So we're looking at which one of them has something that's added onto x inside the brackets, and that would just be part I. So you're looking for a C value, and part 2, II, has a C value. So therefore there has been a horizontal shift. Okay, number 6. Consider the sine function in the form y equals a sine bt plus c plus d. Write the equation of a sine function with no phase shift. So that tells me that my c value is 0 with the following characteristics. I have an amplitude of 3, a period of 4 pi. Remember the formula I taught you guys last time? B equals 2 pi divided by the period, which is 2 pi divided by a period of 4 pi, which the pi's cancel, and I'm just left with a b value of 1/2. And then midline equation y equals 7, that's your d value, d equals 7. So putting that all together, I'm going to have y, let me do that in a different color. So you're going to have y equals 3 sine of b t, no c value, plus 7. Okay, in the next one, I have an amplitude of 5, a period of 0.5 radians. So remember your b value is 2 pi divided by the period, which is 2 pi divided by 0.5, which is really just 4 pi. And a midline value, that's your d value of -2. So putting it all together, here's my equation. Y equals 5 sine of 4 pi t minus 2. Okay, number 7. Given this equation, so we have 5.77 sine of 20.28t plus 14.35 minus 7.5. I want to determine the amplitude, period, and equation of the midline. So let's start with amplitude. That's just my a value of 5.77. Your equation of your midline is y equals your d value, which is -7.50. And then your period is just 2 pi divided by your b value here of 20.28. So I do 2 pi divided by my b value, and I want this to the nearest hundredth. So my period would be 0.31. Okay, it says, how can you use only the values in A to determine the max, the min, and the range? So we did this before. Remember that A is equal to your max minus min divided by 2, and your D value is equal to your max plus min divided by 2. we could use those equations there if we have our amplitude and our d value, or I actually think better than that, because I don't want to rearrange all of that. I'm going to do what I know, midline plus amplitude is equal to your max value, and d value, midline minus the amplitude, is your minimum value. So if you start at your midline and you go up your amplitude, you get your maximum. So I'm going to take my d value of negative 7.50, and I'm going to add on my amplitude of 5.77 to get my maximum value. Actually, this one here, they just want the equation, so I'm just going to get rid of that, and I'm going to pull it down here. There it is. Okay, d value plus a value equals maximum. So there's my maximum value. Now, d minus a equals my minimum in general. So here's my minimum. Your d minus your a is equal to your minimum value. And then we want to find a way to state the range. So range of your sinusoidal function is going to be d minus a less than or equal to, because that's your minimum, y less than or equal to your maximum value, d plus a. So the range in this case here is going to be in between the minimum and the maximum. So between the minimum and our, oops, I wrote that was backwards, our minimum, negative 13.27, and our maximum, negative 1.73. Okay, this is our last example here. So the graph represents a sine function in this form here, and they've given you the graph. We want to determine and the max and min values are integers. So we want to determine the amplitude and the midline value. Now the reason they told you that the max and min are integer values is so you know it goes up to, for example, whoops, if I go up here, that's exactly 1. So my maximum is 1, and my minimum is negative 5. Minimum equals negative 5. So to determine my amplitude, that is going to be max plus min divided by 2. So negative 4 over 2. Oh, I'm doing that backwards here. Let's try that. It's max minus min. I was wondering why I got a negative value. Max minus min divided by 2. So that's 6 over 2 is 3. My d value is going to be my maximum plus my minimum divided by 2 because it's average. So 1 plus negative 5 over 2. So that's negative 4 over 2, which is negative 2. Okay, so I've determined the amplitude and the midline value. Determine the period of the function. Okay, so looking at this one here, let's draw in our midline just to see where that is at. So my midline is at negative 2. There we go. Okay, and I can see from my equation I do have a shift, so I'm not starting right at the midline. So what I'm going to do is I am going to, instead of counting a hill and a valley, because the hill, it starts to the negative, remember we always want to keep it positive, I'm going to start from here, maximum, to this next maximum, because period is a horizontal distance. So I want to know the distance between there and there. So first thing I need to do is figure out what my scale is. So we look at our pi and see how many pieces it's cut into. 1, 2, 3. So the scale of this is going to be pi divided by 3. So we're going to count how many ticks over we went from the maximum to the maximum. So from the first maximum we went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I went 12 times over, and each time is a third of a pi. So that's just going to be 4 pi, which means my period is 4 pi. Okay, so it says determine the values of A, B, and D. We've already done A and D. Let's do B. So remember, B equals 2 pi on top, over period 4 pi. My pi's cancel, and I'm left with a half. So I want to write the equation of the function. So I'm going to have y equals 3 sine of bx plus pi over 6, and then all plus d, or in this case minus 2. Now, if I have an equation here, I would definitely check it to see if I'm right. So I'm going to look at my graph that I'm given, and I'm going to put this equation into my calculator to see if they're the same. Now, there would be absolutely no point in doing that unless we use the same window setting. So really important. I have to have the same window setting. So I can see on my diagram I went from -3 pi to 5 pi, and I already figured out my scale to be pi over 3. My y values go from -5 up to 2, and it's going up by thirds. So I do my window setting, and then I do my equation. There's the equation we just figured out, and you can clearly see that those are the same graph. So that, since the graphs are equal, I know that my equation is correct. Okay, and last part of this question, determine to the nearest tenth the value or the function value when x equals 11 pi over 6. So that's an x value, and when x values are given, y values are needed, we always use trace. So I'm going to go back to my equation here and my graph and do trace of 11 pi over 6, which is what I did over here. So I did trace of 11 pi over 6, press enter, and to the nearest tenth I get a y value of -2.8. Okay, so a little bit of a longer lesson, but let's put it all together. If sine doesn't start midline on an upswing, there has been a horizontal shift. If there's a c value in the equation, a number added or subtracted inside the brackets, there's also been a horizontal shift. If the max and min are not the same number opposite sign, there's been a vertical shift. Remember that that vertical shift is your d value in the equation, and y equal to d is your midline. Again, little trick here, not on the formula sheet, but worth memorizing. Midline plus amplitude is max. Midline down the amplitude is the minimum. Did you guys know that math puns are in fact the first sign of madness? But we all knew I was a little crazy to begin with. This just proves it, I suppose. So you guys have an assignment, number 1 to 14. Detailed solutions are on D2L. I hope this video helped, and I'll see you for the next one.